everyone. Today we're going to differentiate these two functions here. And so we're going to apply the chain rule and product rules and trig differentiation in a bunch of different ways. So for number one, we have the cos of the ln of sine x. Okay, so let's start off by, we're going to do the derivative of cos is negative sine. So we're going to have negative sine of ln of sine x times the derivative of what's inside, right? So the derivative of what's inside is the derivative of ln is 1 over whatever that is. So that's times 1 over sine x. And then again, the chain rule another time times the derivative of what's inside of the ln, i.e. the derivative of sine x, which is cos x, okay? And so now we have, let's layer this with different colors. So we have y is the negative sine of the ln of sine x times cos x over sine x, which is cotan x. And I think that's as far as we can go. That is most certainly as far as we can go. And so here is our derivative. So sorry, I did not put the y prime. That's y prime for the derivative function. Okay, and so here's our final answer. Now b, I think, will be a tiny bit more challenging because we have an exponent on the sine. We have sine squared, right? And I'll just remind you that we can write this as the sine of x ln x all squared, just so you can imagine how the power rule within the chain rule kind of applies, okay? So if that's how we write our function y, then our derivative function y prime is going to be the exponent 2 will multiply out front, so we'll have 2 sine of x ln x times the derivative of sine, which is cos, so times the cos of, again, x ln x, times, by the chain rule, times the derivative of the expression inside the brackets. So times, now we'll have to use the product rule for that one. So I'll use square brackets for the derivative of x ln x. That'll be the derivative of x times ln x. So that's 1 times ln x plus x times the derivative of ln x. And we know the derivative of ln x is 1 over x. And so these guys will cancel out. And so cleaning this up a little bit, we get y prime, our derivative function, is 2 sine of x ln x cos of x ln x times, x is going to cancel out, so we get ln x plus 1. That's nice. And you might recognize from your trig identities that this is 2 sine of something, cos of something. And there is an identity that says 2 sine theta cos theta is equivalent to sine of 2 theta, right? And so we can clean this up a bit and have a simplified expression for our derivative function. That is the sine of 2x ln x times the ln of x plus 1. And here's our result. So another few derivatives that might prove to be helpful in your studies. Again, just remember to always incorporate the chain rule as many times as needed. Trig identities can always kind of come in helpful when you're simplifying your expressions down. And I hope this helps. Thanks for watching.